Alrighty, so I know everyone's in here is actually paying attention. Everyone has their notes out right now. Everyone filled in everything. So everyone is super excited to be here. Everyone except for that guy. So let's all at least pretend for me. Can you pretend? Yeah, you can. All right. So class.
Yes.
See, that's a lot better. That's a lot better. Now, you guys ready for ooh and ah?
No.
You ready for ooh and ah?
Oh my god. You're right.
Yes, ooh and ah. Okay, ooh. Ah. Anyway, I have a working smartboard now. It was it was procured from someone's classroom. Anyway, so I can actually write down the notes on here, so I'm hoping you guys could actually follow along. And if you go back to the videos, I do have the videos, and this actually works a lot better with my videos versus just copying in my answers afterwards. So let's see right here. So everyone should be on this slide. Area, other basic graph models. So yeah, right here. So area of a rectangle is going to be the height times the base. A triangle area is going to be 1/2 height times base. But now we're going to have given the area under a graph. Area under a graph. So that means it's actually going from the line that we have down to the x-axis. But in this case, it's actually going to be the time axis. So I'll draw it for you here in a moment so you can see this. Now, in my formula that I have right here, my velocity, which is change in x, right? My change in position over change in time. So the base, which is left and right in these graphs, is the, say time. Yeah, time. So delta t is my base. Height. Up and down. Up and down. This one's going to be my velocity. My average velocity. What kind of graph is this? This is a velocity graph. Which you can identify because that's a change in time over position. A velocity graph is a change in time, position, or position over time. Better way to say it. Yeah, position over time. And area. So when I actually do this, and I'm actually finding the area of this, this is actually going to give me my delta x, which is my change in position, sorry. Which is the same as saying displacement. Displacement. So for all those people not taking notes, when do you think I should actually do a notebook check?
Next month.
Friday.
Friday?
Or Monday.
But for all those people, huh?
Next week.
Next week?
Next week.
Next week?
Yeah.
Next
So
week,
so
Sunday.
if I like randomly drop hints that a notebook check is gonna be coming up and making sure everyone has all these notes, everything's set up, and we get a grade for that. So are all these notes gonna be filled in magically over the weekend? Maybe, I'm hoping. Okay. All right, so let's use this information now. Displacement is what I'm looking for. So displacement from 1 to 5. So I'm starting here, 1, and I'm going to 5, which is right there. What shape is that? A triangle. So I'm going to call that one my area 1. And what I'm actually working towards, what I say this is actually supposed to give me, it was the last thing I said. That was supposed to give me my change of position, which is my displacement, right? So I'll write out my whole thing. So it's delta x is going to be equal to, it's a triangle, so that's 1/2 base. What's my base here? 1, 2, 3, 4. Yeah, it's 4. What's my height? 2. So I have my equation. I have everything written in and filled in right here, so I could do the math. So what's that going to give me? For what? Now, think about this. My displacement was measured in what? Meters. Write yourself a note for this because a lot of people keep getting this wrong. Displacement is in meters. Velocity is in meters per second. Acceleration is in meters per second squared. So if you're having trouble with that, you know, write it down in your notes to make sure you actually have it. So when I ask Mario later on, I'm going to be like, hey, Mario, what are my units for acceleration? Can you tell me? Exactly. You zoned out a little bit there? Okay, so I said displacement is in meters. Velocity is meters per second. And acceleration is meters per second squared. Those are the units. So when I ask you, those are the units you should be having. All right, let's look at the next one. From 5 to 10. From 5 to 10. I'm going to make it into 2 parts. From 5 to 10, I'm going to do 2 parts. Why am I breaking it into 2 separate parts? What formulas do we have? And a? We have a triangle and a square, right? Did I give you the formula for a trapezoid? Say no. I didn't, and I don't like doing that because it's easier to just do it as triangles and rectangles and breaking them up. So we have from 5 to 10, I have a rectangle here and I have a triangle there. So I'm going to call this one a 2 and this one a 3. All right, so for A2, this is going to give me my, so from my second triangle, what's my base?
3.
It's what? 1, 2, 3. You guys see that? Okay, it's 3 this way. Times my height, which is 2. That's going to give me 6 meters. Let's do the next one for the third area, because I'm asking for a total from 5 to 10. So what's going to be the base from 8 to 10 here? 2. So it's 1/2, 2 times height, which is
2.
which gives me so my displacement from 5 to 10 would be right there. That's from 5 to 8. And this one here is 8 to 10. So to get both of them together, I need to add my so I add together my two displacements, which is going to give me a grand total of 8 what? 8 meters. There you go. You okay so far? All right, let's do this last one. The last one is from 13 to 14. So 13 right here, 14 right there. And I'm going to call that one area 4. Area 4. So that is a triangle, right? That's a triangle. So delta x, my fourth, is 1/2. My base, what's the base there? 1. And what is my height? What's the height? What's the height right here? -2. So this point right here is what I'm looking for. So that's -2. Do a little math. Is -1. Okay, so with a negative displacement, so I'm going to use squares that are right here, okay? So if I'm starting right here in the center of the room, that's 0. And if I end up with a negative displacement, so -1, you guys are going to move just 1 to the left, right? And if it's positive, that would mean my displacement start to end would be 1 to the right. So in my displacement, that's telling me how far I've gone from my start. Questions? I know you guys are trying to get it all written down, right? All right. Yeah, you people. Right about, yeah. I want you guys, you're going to do the displacement from 0 to 2 and the displacement from 2 to 6. So use the information we just did right now and go. right, so we identify the shapes and start there. All right, Sancho, what shape do we have in the first one? 0 to 2.
Square.
Square, very good. So that means I'm going to call this one area 1. So my change in x is equal to, what is my base? What is my height? So my displacement is 4 m. Very good. 4 meters. Good job. All right, this next part. This next part is asking from 2 to 6. 2 to 6. So starting here, going all the way to here. Can I break this up? Yes, I have 2 triangles. So I'm going to break it up into 2 triangles here. I'm going to call this one A2, this one A3. So A2 is a triangle, so therefore my formula is going to be delta x for 2 is my base, so it's 1/2 my base, which is, my base here is 2, count 2 over there. My height is positive 2 there on that one. It's negative 2 on the next one. So that area is going to give me 2 meters. Very good. All right, so now if I was to do delta x for my third area, again triangle, so it's 1/2. My base is 2. My height is negative 2. Very good. That point right there is negative 2. So my answer is going to be negative 2 meters. All right, what is the displacement from 2 to 6? So to get displacement for 2 to 6, it's going to be plus so I'm adding those 2 displacements together. So my 2 plus negative 2 is going to give me 0. 0 meters. Just randomness right here. What if I were to ask you from 0 to 6? What would you do? You just add them all. That's usually what happens though. And right now I'm trying to teach you that in steps and setting you up. So if I go to get from there to there, I would just add them all together. So if I were to add them all together, my total displacement would be 4. Because from here to here is 0, and that's 4. My total displacement is 4. Make sense? Kind of? Hopefully? Yes. Okay. Now we're actually looking at other types of basic graph models. This time we're actually be looking at the acceleration. So base, same thing, base, all these are actually going to be delta t. Which variable is the height? This is going to be here, which is my acceleration. What kind of graph is this? It is an acceleration graph. That is my acceleration graph. And when I'm finding this one right here, when I have an acceleration graph, I am finding the velocity. I'm finding the velocity. So here's an example of this graph right here. So this would be a velocity over time. So this is a graph of the acceleration. So in the previous one I drew, this over here, this was the position. And now for acceleration graph, you look at it, this now has velocity over here. So it's important to identify what graph we're looking at. Because you're going to have to identify the graph first before you can decide if you're going to be solving for my velocity or solving for your displacement. All right, acceleration versus time. So here is an acceleration graph. The acceleration graph, say a race car driver is cruising at a constant velocity of 20 meters per second. She nears the finish line. The race car driver starts to accelerate. The graph showing gives the acceleration of the race car as it starts to speed up. Assume that the race car has a velocity of 20 meters per second at time t equals 0. Find the final velocity of where'd it go? Find the velocity of the driver when she reaches the finish line. So, final velocity. So we know what's there. Final velocity over here. So what shape is this? Triangle. It's a triangle. So we're finding the area because this is an acceleration graph. If I find the area under the curve, this is going to give me the velocity. So I'm going to say the velocity is equal to my shape is a triangle. One half. What is my base? What's the base here? 8. What's my height? Do the math. 24 what?
Meters per second squared.
What are we looking for here? And what did I say the units are for velocity? Meters per second. That's important. So that's why I had you write it down. So if you know what it is you're looking for, you should know the type of units it's supposed to have. Acceleration is going to give me per second squared. Velocity is just going to give me per second. And position is just going to give me a linear distance. So it should be just meters. All right. Questions, concerns, complaints, conspiracy theories? Nope, we good? All right. So that being said, we got this one here. What is the change in velocity from 0 to 2? What shape do we have? Square. So we can call that one A1. So from 0 to 2, if it's a square, that is going to be my velocity is going to be equal to my base, which is 2 times 2, which is 4 meters per second. What would the corresponding velocity graph look from 0 to 2? So if it's a velocity graph, okay, this is going to be my position, and this would be time. Let's say this is going to be, that's 1 right there. This is, in this case, 4. And this one right here is 0. So the graph of the velocity, because the velocity is going to give me the slope of position over time. So it would look like this. It would be positive. So it is 4. It's 4 meters every 1 second. So there's a graph for that one right there. Just an easy sketch. All right, you okay? So we have between 0 and 1, so that's a graph of that one right there. That's a graph of my velocity. over here, what would the corresponding velocity time graph look like from 4 to 6? All right, let's do a 4 to 6 now. From 4 to 6. What shape? Square. So if it's square, I'm going to call that one a 2. So that's going to be my second velocity. This one's going to be square, so it's just, what's my base? 2. What's my height? What's the height of this one? Negative 2. It's going to right here, isn't it?
Yeah.
So it's negative 2. So my velocity here is going to be negative 4 meters per second. So that means that the slope, so my velocity here, it's going to look like this. My position graph over time, call that one 0, call that one 1. And for this one here, it would be like this. Oh, wait, I got to move my 0. Sorry. So this one right here is 0, and this is negative 4 down here, and this is positive 1. So from 0 to 1 right here, the time, it has a slope of negative 4, so it's going to go here like this. My slope is negative 4, so it goes down 4 every second. That's how I sketch those. So it's down 4 every 1 second. Make sense? Yes? No? Maybe? Possibly. Everyone's looking at the time, like I'm running out. There you go. Summary. So you guys all have that homework assignment that I gave you guys. So I think I gave it to you on Friday. All right. So go ahead, work on that. That one's also going to be due Friday. Make sure you like, share, and subscribe. Hit that notification button. Support my channel. Buy stuff for my merch store. And yeah, I already said hit the notification, right? Okay.
Right.